Back to another exciting day in mathematics. Warm up 123. Michael Jordan's on the screen. Let's get started, please. Today we are moving on. We're continuing on the applications portion of the course. On Friday, I left you guys a video lesson, but I did see some of you were absent on Friday, so I'm going to go over one problem, kind of like to cover that section. But you're going to see how it transfers really well from what we've been doing. Other than that, let's get started, please. It shouldn't take you long. Copy and go. Nine. Hands if you got 9. Looks about right. All right. Variance. What'd you get for variance? Bless you. Santi. Bless you. 54.8. Looks about right. Standard deviation. Pass someone. Amelia. Bless you. Standard deviation. 7.4. Bless you. 10.4. So that gives us 16.4. And then on the other end, that gives us 1.6. So our norm is from 1.6, bless you, to 16.4. Z-score for 15. Pass someone, please. Aaron. 0.81. 0.81 is to the right of mu, about right here. And our range is 20 minus 1, that's 19. All right, send that in, please. Copy the agenda. Warm up 123 is done. We're still on normal distributions, and we are in application. So for tonight, you have 2 application problems only. Whoa. All right, under the desk, guys, under the desk. All right. Everybody copy the agenda? All right. Copy the code to access the home play. WDYSZ. WDYSZ. All right. And since we are recording, here it goes. So we have till Thursday of this week. Then we're off for about 9 days for spring break, right? Then after we come back from Easter break and all that, we only have 3 more days for April, but report cards are going out. Oh, yes. So, give me a second. So where was I? Hold on. Oh, yeah. Report cards go out when we come back from Easter break, which means, here it goes. Y'all ready? Logan, you ready? All right. This week is the last week that I'm accepting any late work or any work that you owe me. After the break, I'm not going to accept any more late work or anything else that was due. It's your responsibility. Now, I believe, now correcting me if I'm wrong, I've been pretty lenient in regard to that and giving you guys opportunity after opportunity after opportunity after opportunity after opportunity to the second power to turn in your stuff. And still some of you keep playing. I mean, come on, guys. So, this week and this week only, and I'm done. I'm going to be on vacay. I'm going to do probably a Star Wars marathon or something during the breaks. Oh, yeah. I'm going to do the whole thing. So, I'm going to be out with my Hawaiian shirts. And picture me on my Hawaiian shirt, my recliner, Star Wars. Let's go. Oh, yeah. I got that. So, please, pretty please. It's recorded, so if you need to revisit the message, there it is. Tell your neighbor, when is the last time to accept late work? When is the last time? Last time. Wow. Thursday of this week. To be specific, here it goes. Let me get the date in front of me. Yes. Say it again? Yeah. April 18th, last day. And once we come back from break, I'm thinking I'm already going to have you guys bring your textbooks back. Something like that, yeah. All right, so with that said, tonight's home plate looks like this. Get a Cornell note in front of you, please. I can define and compute normal distribution. I can define and compute normal distribution. I can define and compute normal distribution. And as I mentioned before, I am going over one problem that I left for Friday. I just want to make sure everybody's on the same page. Yes? Yes, Mr. Q. All right, good. So we've covered the different probabilities so far. We've covered the different variables. We started with discrete. From there, we're moving on to continuous. That's where we're at right now. And then I introduced the normal distribution. So each one of those have a name. Tell your neighbor the names of those, please. Tell your neighbor the names of those without looking at your notes. All right, type it on your screen, please. Type it in on your screen, the names of those. And reminder, stay off those cell phones. My goodness. Ten. Oh, my bad. 9, 8, 7, 6, 5. 4, 3, 2, 1. Thank you, guys. And it looks something like that. The normal curve known as symmetrical. Then we got skewed left and skewed right. All right, let's call them those cell phones. If I see you on the cell phone, I'm going to take it away. You pick it up after school. Yes? Yes, Mr. Q. All right, good. So, from there, we move on to percentages. Remind your neighbor what is the percentage for the normal range of that bell curve. What would be the percentage for the entire normal range? Normal range, what would be the percentage? All right, type it on the screen. What would be the percentage for the normal range? Normal range. It's the normal range. All right, thank you, guys. Here's the normal range. The normal range should be around 68%. 68%, yes? All right? So, by now we know the formula for z-scores, yeah? All right, so on your on your paper? Write this down, please. Z equals a number minus mu divided by standard deviation. So far all year, I've been giving you guys plenty of practice finding the z-score. On Friday, I gave you guys a video lesson to apply that to a word problem, finding the z-score from the word problem. We're going to go over one together. However, today, we're moving on to where the problem, they don't ask us for the z-score. They ask us for the number itself, which is this one. So how do we do that, Mr. Q? Well, first, we need to leave x by itself. How do we leave x by itself? Well, I need to get rid of standard deviation first. Is that correct? So that means I multiply times standard deviation. Follow along, please. Times standard deviation. That leaves me with z times standard deviation is equal to x minus mu. I still need to leave the x by itself, so what do we do at the end? Plus mu plus mu. So we end up with z times standard deviation plus mu is equal to x. And this is the formula we're going to be using today. In other words, it looks like this. To find the x value, I need to multiply a z-score times a standard deviation, and then at the end, add mu. Okay, that's going to be our new formula. But where does it come from? It comes from the z-score formula, or the standard score formula. Anybody follow? Yes? All right. So, with that said, Friday, we covered these kind of problems, where we gave you a word problem, and you needed to find the z-score for that. That one and that one. And then I gave you guys for home play this one right there. All right. So in order to do that one, let's do this one together on your paper. I want you to write example Q. All right. And just write admission charge for movies. That's all you have to write. And we're going to start with our bell curve on this one. So get our bell curve going. We got mu, first standard deviation, second standard deviation, third standard deviation, minus 2 standard deviations, minus 3 standard deviations. All right, so let me read you the problem. It says the average early bird special admission price for a movie is $5.81. What is another word for average, everyone? What is it? Mean or mu. So let's label that here, $5.81. So our mu or our mean is $5.81. If the distribution of the movie admission charge is approximately normal, the standard deviation is 0.81. So our standard deviation is approximately 0.81. So, from there, it says, what is the probability that the randomly selected admission charge is $3.50? Well, let's use our standard deviation first to see where we're at. If mu is 581, add 81 cents to that, and that takes us to a first standard deviation, which is a total of what? $6.62. Let's go to the next standard deviation up. So from 662, add 81 cents. That gives us 743. And our third standard deviation, if you add 81 cents to that, that gives us 824. So that's on the plus end. Go to the negative end. 581, take away 81 cents, that leaves us at $5. Take away another 81 cents, that leaves us at $4.19. Take away another 81 cents, that leaves us at 330, 30 what? 8? $338. Okay. So, question. It says, what is the probability that the randomly selected admission charge is 350? So where's 350 at? So here's 5, here's 419, here's 338. 350 is close to right here. So label your area right here. That is $3.50. $3.50, approximately. They want the probability. What does that mean, Mr. Q? That we need the area to the left of that. The area to the left of that. All right, so how do we find the z-score for the 350 in dollars at that point? Well, what's our formula, everyone? Z is equal to what? X minus mu over standard deviation. All right, find me the z-score, please. 350. Let me label the 350 above instead, so like that we don't get confused. $3.50 is there. Okay. And the rest of you that were here on Friday, thank you for taking copious notes and doing all your home play from the video. Appreciate it. All right. Looks like Austin's done. Very good, Austin. You should have the z-score by now. Help them out with the setup, Amelia. What did you write for X? 3.5 or 350 minus mu, which is 581, divided by 0.81. Thanks, Gavin. All right. So, Austin, T, what'd you get? Negative 2.8. Hands, have you got something like that? Yes? Okay. So, negative 2.8 is this z-score, negative 2.8. Let's see if we're right on it. Here's 2, here's 3. Yeah, it's pretty close, right? Okay. However, we need the percentage to the left of that. Remind your neighbor, what do we do with this number? Then Austin's going to enlighten us. What do we do with that number from there? All right. Austin, pass them on. What do we do from there? Max, what do I do with that number? Very good. We look at our charts on the left side and look for negative 2.8. All right. Very good, Max. Negative 2. It's right here. 0.8 is right here. So where the two meet is right here. Did everybody find that number? All right, tell your neighbor that number, please. What'd you get for that number? All right, Brandon Doherty, what was that number? I did 2.08? Oh, my bad, my bad. Yeah, I did that to see if you guys were paying attention. All right, 2.8. Brandon Doherty said, Mr. Q, you did 2.08, but it's supposed to be 2.8. Here's 2.8 with 0, 0. So that number is It was 2.85? 2.85? All right, so 2.85 is over here. Brandon Darty. 2.85 is there. So if we move this over, we are at 0.0022. All right, so I guess somebody said 2.85, and that gives us 0.0022, which is what in percentage? Move this twice, and that gives us 0.22%. What does that mean? Well, let's read it. What is the probability that a random selected admission charge is less than $3.50? How much is this in percentage? I mean, that's the percent, but what is it close to? Tell your neighbor. Close to what? Close to 1%, which is very low, right? That a theater is going to charge how much? Less than $3.50 per admission. So that's how we did those, and that's how you do those from Friday's lesson. All right? We good, right? Because all we use is this formula, and then look for that number on your chart and convert it into percent. Okay? All right, thank you, guys. Send me your notes, please. Which brings us to this one, example Star Wars Q. Itemized charitable contributions. And it reads, the average charitable contribution itemized per income tax return in Pennsylvania is $792. What does that mean, Mr. Q? Let me elaborate. Charitable contributions. For example, you know how some of you like to help out outside of your either sports or academics? You like to do other things, some of you. Well, there's families and some of you that are going to maybe help financially later on institutions in regards to giving monies for something. For example, some of you haven't started working yet. You are going to start pretty soon. Well, I already told you that 30% of your check is gone. So if you work 40 hours at $20 an hour, that's 4 times 8, 32, $320. Multiply that times 3, that's $100 less, so you're only going to get 200 and something bucks for your check. You're like, what? Yeah. The rest is gone in taxes that we pay for. You know, California, they have a bunch of taxes. However, let's say you have in your heart and in your mind, you want to contribute to the hospital here in either in El Centro or Brawley, and you want to give so that they can use those $20 or whatever money you want to give a month for them to do research to help people that are going through cancer or through whatever illness, and you give that every month. Well, guess what? At the end of the year, when you do your taxes, especially this month, it's tax month, you can report that, and they give you back credit for that money that you gave. What does that mean, Mr. Q? That some of the taxes that they took out from your check, they actually give you back. You're like, oh, because they're saying, all right, we're giving them a break because they're contributing to other things, and we're going to give them that money back. That's what charitable contributions mean. So, in the state of Pennsylvania, the average yearly contribution by citizens is $792. If you break it down, it's close to 60-some bucks a month. It says, suppose that the distribution to the contributions is normal. What is that saying? That it's a normal curve or it's a normal bell curve. And the standard deviation is 103. And they want to know the limits for 50% of that graph. So, start off together doing this one from the bell curve. So let's sketch a bell curve, nice and neat. Here we go. So now some of you are very focused, appreciate it. because some of you are not going to know what to do when we get to these on Wednesday. Before we go on vacay, you're going to repeat this on paper. Not on quizzes, on paper. I'm just giving you a heads up. So what is the first step? We need a bell curve. There it is. There's mu. There's the first standard deviation, second standard deviation, third standard deviation, negative standard deviation, -2 standard deviation, -3 standard deviation. All right, so let's label stuff. It says the average charitable contribution. What does average mean? Mu. What is mu? 792. What else do they give us? Oh, Mr. Q, they give us the standard deviation, which is 103. So let's label standard deviation. It's approximately 103. All right. So before I label my standard deviations by that, let's see what they're talking about in regards to the 50%. Ready? Question. Look up to the screen. Remind your neighbor, what am I pointing to at this moment? What am I pointing to? The norm. Remind your neighbor, what is approximately the percent for the norm? What is the approximate percent? 68, is that correct? Approximately. But they only want how much? 50%. So that means, am I going to go beyond those? No. Because on one side, if this is 68, that means on one side it's 34 and the other side is 34. Is that correct? But they only want how much? 50. So that means I go how much to each side? Let me repeat that again. This whole thing is 68, right? Which means on the left side of mu is 34 and on the right side of mu is 34. So if they want us to stay at the 50 mark from the mean, that means how many to the left? How much percent? 25 and 25. That means our z-score should be somewhere here and here. We need those z-scores. And why? Well, because this section right here is 25%. And this section right here is also what? 25%. How do I know that? Because it says here that it's a normal distribution. So if they're wanting to focus on the 50%, that means half of it goes to one side, half of it goes to the other. Are we there so far? Okay. So now that we focused on that, let's label our standard deviation. Here we go. So if we start at 792, add 103, our first standard deviation should be at 895. Yes? Yes? Add 103 again. Let's go to our second standard deviation. Our second standard deviation should be at 998. And our third standard deviation is what? 998 plus 103, that's 1,101. That's on the positive end. Okay, let's go to the negative end. 792 minus 103, that gives us 689. Second standard deviation on the negative, that gives us 689 minus 103, that's 586. And the third standard deviation, 586 minus 103, that's 483. Are we there so far? Okay, so now that we have that, notice that this time they don't give us a z, but they also don't give us the number. You're like, what do you mean, Mr. Q? Yeah, because they're asking us, what are the limits in regards to how much people contribute? How much do people contribute on the low end and on the high end? So check this out. We know that the mean is 792. And by standard deviation, it keeps going. But what is it here where the red is at? I don't know, Mr. Q, because that's only they give us a percentage. Okay, so then let's backtrack it. Here it goes. Y'all ready? Put your thinking caps on. In order to find this z-score, look up please. In order to find this z-score, we need the area to the left. Is that correct? We need this area. So, what is the percentage to the area of the left of this z? Think about it. Here's mu. How much is this little section here? Tell your neighbor. 25. So how much is this in green? Aaron, how much is this green portion? Let me highlight mu again. Here it goes. Some of you are a little confused. Here's mu. Here's the middle. We know that everything to the left, all the way to the end, is how much, everyone? 50. Question, how much is this little section on the right side of mu on the right side of the z next to the mu? That's 25%, right? So how much is the percent in green? 25%. That is correct. Now that we have the percentage, what do we do to find the z? Make that into what? Decimal. What is the decimal form of that? 0.25. All right, let's go to our chart. Let's look for that z-score. Yeah, somebody please. Bah. Let's go to our z-score, our z-chart. We're on the left side. We're looking for 0.25. Let's see. 0.25. Where's 0.25? Let's see. 0.22. 0.25 is right. Oh, not there. Let me scoot up. I think Brandon Darty knows. Hold on. All right, Brandon Darty, what is it? .25. Negative 0.67. Look up, guys. 0.25. .25, the closest one is this one. Yes? Yeah, it's on the negative side. So what is that in the z-score? Z-score is negative 0.607 or negative 0.67. That is correct. So my z-score for that, this one, is negative 0.67. Whew, all right. So we got this one. Now we need this one. Thinking cap on. Here you go. This one is to the right of mu. Is that correct? What is this percent right here next to between mu and that z-score? That's how much percent? And how much is everything to the left of mu? Once again, what is everything to the left of mu? Sam? Everything to the left of mu. 50. So we got 50 plus how much? Plus 25, that gives us what? Yeah, so all of this up to that z-score, now we are looking at 75%. So find me first the decimal form. The decimal form is 0.75. Go to your z-chart and find me that z-score, please. Then Aleshka is going to enlighten us with that. 0.75. All right, Aleshka, what's close to 0.75 in z-score? 0.77 is the closest. .75, did everybody find it on the chart? And what does that give us in z-score? Thank you. 0.68. Okay, once again, some of you are somewhere else. Here it goes again. 0.75 on the right side. Where's that at? Let's see. 0.75. The closest is this one. 0.7517, yeah. But in z-score, what is that z-score? 0.6 plus 0.08 is 0.68. Come on, people. Bah. All right. Are we done, Mr. Q? No. Those are just the z-scores. Now we use our x equals z times standard deviation plus mu. That's for one x. And for the second x, same thing, z times standard deviation plus mu for the second one. So we got x sub 1. We're going to start with this z-score. So negative 0.67 times standard deviation. What was our standard deviation? 103. Plus mu. What is mu? 792. And that's going to give us a number for one end of the contributions. So calculators calculate. Looks like Austin got this one. All right, Austin S., what'd you get? 722.99. That's on the low end of people contributing to charitable foundations. Let's go to the up end, x sub 2, and now we use the second z-score. 0.68 times standard deviation, which is 103, plus mu, which is 792. Austin S., pass someone. Brandon Doherty. .68 times 103 plus 792. What? 862.04. All right. So here's a question. It says, suppose the distribution is normal. Standard deviation is 103. Find the limits for the middle 50% of contributions. So the limits of contributions is from $722.99 to $862.04. 10Q. Woo! That was good. I like these. Good thing you guys do your home play, right? Get the extra practice in. Appreciate that. All right, send me your notes, please. Sure you zoom in, please, because I can barely see some of yours. All right, from 1 to 5, how comfortable are you with that so far? Where are we at? Fours, fives, okay. All right, let's go to example MJQ. Let's start setting this one up together. Here we go. Get a bell curve going. Just want to make sure that you got the process complete. Step 1, set up your bell curve. And the mean for this one, for new home sizes, let's see. The average size is 1810 square feet. Standard deviation is 92 square feet. And in this case, they want us to focus on what percentage in the center? 70%. Which means what? From mu, I go on one direction, how much? And on the other direction, how much? Let's see, Cole. How much on each direction from the mu? How much? 35, that is correct. But we know that the norm is 34 and 34, is that correct? So that means our limits are going to be here, right next to the first, and right next to the first standard deviation. That's going to make it that 70%. So what does that mean, everyone? What is this section all the way to the z in percentage? Cole said it was what? 35%. And this section is 35%. So with that said, to find this z-score, I need the area to the left of that. So you know how much is the percentage, the area to the left of that z? How much is that in percentage? 15 is correct. 15%. You know how to change that into decimals, finding the z-score. However, look up. How much is the entire area from here all the way to the other z? 35 plus, that gives us 85%. That is correct. 85% for the entire area to get to this other z. And now we know how to find those z-scores. That one is going to be for 85%. And then from there, we just substitute those z-scores to our formula, z times standard deviation plus mu. And then we do that again for x sub 2, z times standard deviation plus mu. All right, I'm going to stop right there right now. For those of you that are following on YouTube, there's the home plate for tonight. It's only 2 problems. Make sure you put that practice in. See you guys next time. Peace.